prediction time.
Oh, okay.
He's not even here.
Here's what I'm gonna say. Find
That's how little he cares.
the vector. One vector for the input.
Wait.
Wait, I signed us up for jam session on
Oh,
Wednesday.
is
But we can delete it there.
Okay, I'll add a
know about Polly and Encoders. How you came to the right place. I love this for the theme.
No, there were a lot of open spots. I just like
That's the
No.
Like during class.
It looks so bad. I did not
No
so pretty.
I
How do you like this?
Why does it?
It's actually sort of. I worked on it like an hour back. I said it and then people liked it, but I didn't like it, so I added the color and stuff and like the shape.
But you did that.
But like, I honestly thought it was due yesterday evening.
Just added shapes.
Yeah, I didn't know it was due today.
Yeah, no, it's really good. I like it.
And like,
yeah, you want
more
I have like half.
I'm gonna have a card for it.
Yeah, you will. Whatever.
Oh my god.
Actually, disrespect to Krishna like that.
Hold on, let me get my
I'm
notes
the
out.
oil.
Yeah,
Me too. Did you just
Yeah, they're so good.
I'm gonna make sure I remember to say these because I don't know if we're gonna finish this. I don't feel a lot of notes because I just need like sentences that will tell me what to say. Yeah.
I
But
feel like Krishna's is like the designated.
Alright. Yeah.
Were there less people last Wednesday than today?
Yeah.
You mean the part that I'm presenting? I think they give so. Five.
Most email?
How did
I feel like
there's
I
so
can't
many
present
people.
something without
No.
understanding.
No, this is similar.
Maybe not Jackson.
But like
No,
no,
but
questions.
I have 2:30.
Yeah.
Maybe
I'm pretty
people
sure
care
I'm good. We're gonna get like a.
When do we want to or do our
Do we have to? What if we just don't
Use the
know?
animatic optimize all labels.
Definitely not this week.
Yeah.
Not
Next Monday is also what's for
Yeah.
Well, the next Monday's already taken.
Oh, that's the trick. I'm still
grinding.
Oh, you're right.
Wait, what do you guys add on the? What did I miss on the?
Like probably a 0.
And you're like, we spent a lot of time.
What did we miss on the?
We might not be able
MSCC is good, but like, there's just way too many moving parts.
I know. Yeah.
Did you do 4 or 6?
So, today we have Polly Encoders. So we're going to be observing a way to use multiple transformer models to solve problems and to do it in efficient ways. So it's a really good paper. Let me remind everybody, oh my gosh, it's like nuts, right? It's gonna go by fast. So we've got week 12, 13, and 14 is presentations, final presentations. I hope you guys are putting the final touches on stuff. How's that going? Good, good, awesome, awesome. Oh, it's gonna be good. And remember, slow and steady wins the race or something, like just consistency. Cramming is always super stressful and, everything happens at the same time. So that would be my big recommendation. And without further ado, let's get Jason Case. Come on up. Is it Jason Case or Jason Case? Awesome.
This guy, he's gonna do a class this semester.
I didn't see that one for this semester.
Well, I don't know, this semester, but then
This semester.
yeah, but then he has to go for something. So that's your comment. I don't know. I want to see if he's like doing the next semester.
Not doing it. Wait, did you not get the?
No, I did. I was just like, what it is.
I think you might be here.
Oh, actually, wait.
I do like 3 credits of the intellectual graph. Or just wait for it.
That's fine. So many options.
Why are you all never on fit? That's
I made an
This
animation.
side's better because there's not enough room for 8 of us.
you're never on the camera.
The intro talks a little bit about encoders.
I mean, I think I don't know. Do I smell bad?
Yes.
All right. Yeah. Hello, everybody. We're Jason Case, and today we're going to be talking about the paper titled "Polyencoders: Architectures and Pre-training Strategies for Fast and Accurate Multi-Sentence Scoring." And yeah, this paper was basically published by researchers at Meta AI Research. So the premise behind this paper is basically recently improvements have been made to language understanding tasks using deep pre-trained language models followed by fine-tuning. And this paper basically explores improvements to such tasks that involve multi-sentence scoring. So what is multi-sentence scoring? Given an input context, we essentially score a set of candidate labels and set up common retrieval and dialogue tasks. And yeah, before this paper was published, state-of-the-art generally had two classes of architecture built on top, bi-encoders and cross-encoders. So first of all, what are cross-encoders? So they basically perform full self-attention over those input and candidate labels. And the good thing about them is that they provide really high accuracies. Whereas in case of bi-encoder models, they provide self-attention over input and candidate labels separately, and they provide really, really fast prediction times. Whereas polyencoders basically kind of like takes the best of both worlds. It provides additional attention mechanism that represents more global features. So what it does is that it essentially provides performance gains over bi-encoders and large speed gains over cross-encoders. Coming to the related work section, some of the references that researchers who made this paper used were, so in terms of bi-encoder references, they referred to vector space models, LSI, supervised embeddings, and classic Siamese networks. And in terms of cross-encoder references, they used network CNN-based architectures, deep matching networks, gated self-attention, and transformers.
Yeah, so getting into the tasks that the AI was like set to perform, there were two types of tasks where there was sentence selection and then article search, but there were three like total tasks in general. These are just two kind of generalized I guess, groups for them. So the two competitions that this AI was featured in was the NeurIPS Conv AI 2 and the DSTC7, which I'll go into further here. So the first task was the persona chat database. So this is a dialogue between pairs of speakers, similar to, I guess, our project here. We have two speakers, and they're both given a persona, which is just a description with a few sentences. So like this example was like, I love romantic movies, I work at a trading firm, and I like eating Mexican food. That would describe this person, and the similar sentence would be given to the other persona, and there was just a conversation between the two. The goal was to pick the correct one of 20 utterance choices for that conversation. So there's one actual answer and then 19 randomly chosen answers from the evaluation set, and this was the Conv AI 2 competition. Next, we have DSTC7. So they extracted conversations from the Ubuntu tech support chat logs, which is similar to the persona chat, but instead of like, giving them, I guess, a few sentences, it's actually chat logs that were used for tech support. The Ubuntu v2 database is just a larger set of these tech support logs, and the DSTC7 is taking a subset of these. Of course, similar to persona chat, but this time there are sets of 2 to 10 utterances that the AI is given with one correct one, but the challenge actually expanded more recently. Now there's options where the AI is given 100 utterances with 1 to 2 correct paraphrased responses, and the AI has to choose. There's 100 utterances with 0 to 1 correct responses, in which case the AI has to decide whether there is a correct response in the given set. And then the final one was 120,000 utterances with only 1 correct response. Then the final task was the Wikipedia article search, where the 2016 dump of the English Wikipedia had about 5 million articles. We take kind of a web search scenario similar task where you kind of give the AI a sentence from the article, and then AI has to find which article it came from. Obviously, the article, the sentence that was given to the AI is taken out of, and then it's ranked against 10,000 other articles, and the AI has to correctly find the one that it was taken from.
Yes, so the next section of the paper talked about the methods in implementing the different encoders. So we started off based on BERT with 12 layers, 12 attention heads with hidden size of 768. And this was trained on 3 different corpuses. So it was trained on 150 million examples of like the input representation had the input and label. And this was extracted from Wikipedia and Toronto Books corpus, which contains like text from different books. And another 170 million examples were extracted from Reddit to give it like more dialogue flow, more language similar to like common dialogue. And yeah, the input representation, the input was like sentence or context, and the label was the next utterance or sentence from that context. And it uses masked language model MLM from BERT. And during training, 50% of the candidates were the actual next sentence utterance, and the other 50% was a random sentence from the same database. So this was there to add some more randomness in their pre-training. They trained it on 32 GPUs for 14 days, which is pretty long, I think. And after doing this pre-training, there were 3 architectures for fine-tuning: bi-encoder, cross-encoder, and poly-encoder. And now we're going to talk about each one in depth.
Yeah. So the first architecture for fine-tuning was the bi-encoders. So it basically takes in 2 vectors. So that's the input context and then the candidate label. The equations for both are below. T1 and T2 are 2 different transformers. And then both involve a reduction function, which reduces like a sequence of vectors into one specific vector. There are a few methods that a bi-encoder can reduce the vectors. So one is picking the first output of the transformer, one is computing the average over all of the outputs, and then one is computing the average over like the first n outputs. And then the score is given by the dot product between the context and the candidate vector. And as mentioned before, bi-encoders are generally pretty fast, but they can also be less accurate just because of their speed.
All right, now let's talk about cross-encoders, which are the ones that were kind of slow but really accurate. So we have this little diagram here that just goes through what cross-encoders actually go through in their just life cycle. So first we have both our context and our candidate label. So first we just smack them together, concatenate them, and surround them by a special symbol. And you feed that into a transformer, so the encoder. And this pretty much just outputs a sequence of vectors. So again, this is a result of the exact concatenation of both the context and the candidate label. So the big thing is you can't really cache this stuff beforehand because you have to do all of this stuff at runtime. Right, so once you have all these output vectors, we have an aggregator that just gets the first vector from all of these. And that pretty much gives our context embedding. So our Y context candidate, that's just our embedding that we use to signify the combination of this context and the potential candidate label. And finally, when we have this vector, we want to be able to transform that vector into a scalar. So we do that by applying a linear layer on the actual embedding. So that finally gives us a scalar, and we use that to actually score the context candidate pair. So yeah, the end embedding is obviously a result of both the context and candidate. So you can allow for a candidate-sensitive input representation, which means this is going to be more accurate in the end. The trade-off, though, is that candidate label embeddings can't be cached beforehand. So you actually have to append both together every single time you want to make an inference. So this can be really expensive, and training time is like a lot longer than bi-encoders.
Okay, so now we get to the beast. What is a poly-encoder? Sorry, Mike, thank you. So a polyencoder, all we know so far is that it's faster than a cross encoder and that it's more accurate than a biencoder. It does this by essentially being an augmented biencoder, a biencoder with some extra pieces that make it kind of act like a cross encoder, but in a much more efficient way. So I've got the whole big old machine over there, the factory, that is the polyencoder, and we're gonna go through it piece by piece. So the first piece on the right over here, go ahead, there you go. The first piece on the right over here, this is exactly the same as the biencoder. It's gonna take the candidate and give out a single vector that represents the semantics of that candidate in one vector. The result will be slightly different than when we train it for a biencoder, but it is the exact same mechanisms. We're just training it for a slightly different thing. Now over onto the context. The first step that we're going to do is we're going to take each of the tokens and put it into a transformer. And importantly, we're going to be using every single token's vector from this transformer. So each output right here, each of these vector embeddings, is going to have information both on the token itself and on how that token relates to the other tokens in the sentence. So we're going to end up with a whole series of vector embeddings here, and we need to somehow turn all of these into one vector that we can compare to the candidate's vector. So we're going to do that with these things called codes. Codes feel a little bit weird still to me. You can kind of think of them as like parts of the sentence that we want to extract, or like different situations that you might run into in a sentence. Each code has a query, code 1 through code M, and that's just a vector. And we're going to do a weighted average of all of the token vectors right here, based on how relevant they are to each of these codes. So if they are parallel, then they're very important, whether they're going with the code or against it. So we're going to take those into account a lot. We're going to weigh those very highly. But if they're like perpendicular, then they don't really have anything to do with that code, so we're just going to kind of ignore it. So we're going to assign a weight to each of those vectors and then take an average based on that. So the result is a whole bunch of new vectors up here, each of these embeddings that have to do with each of the codes. And then we're going to repeat that process for the candidate. We want to see for each of these candidates, how important is each code to that candidate. That's how we're going to get, so once again, we're going to see how parallel are each of these code vectors to the candidate, which has its own vector, and then we're going to weigh them respectively. And the result is going to be one new vector that is the average of each of those with its weights. And then finally, once we have that, we can just do a dot product exactly the same as we did in the biencoder for maximum efficiency. So this way we can get out the different parts of the sentence and still take them all into account without like overgeneralizing, while still just being simple operations like a biencoder. Okay, polyencoder.
Nice job.
Okay, now we're going to jump into the experiments we did for biencoders, cross encoders, and polyencoders. So we did a variety of experiments to test model architectures and training strategies over all the tests that Krishna discussed earlier. And for the metrics, we measured recall K over C, which that's the proportion of relevant items found in the top K recommendations. And also looked at the mean reciprocal rank, which is a measure to evaluate systems that return a ranked list of answers to queries. Okay. So first we're going to dive into investigating fine-tuning. We tested a large number of negatives by considering batch elements as negative. So for biencoders, we increased up until 512 elements, but then for cross encoders, it only went up into 16 because it's too computationally extensive. And it was noticed that there was higher performance with a larger batch size or more negatives, as you can see here. And then two optimizers that were incorporated. One was Atom with a weight decay of 0.01,
And ADAM is a replacement optimization algorithm for stochastic gradient descent for training deep learning modules. And then we also looked at ADAM Max, which is an extension of ADAM. And then for validation performance, we also did validation performance for fine-tuning various layers of BERT weights. Yeah, and these are what we got. And here you can see that the cross-encoder did the best than any previous poly-encoder and bi-encoder for each of the tests.
So, kind of as expected, the polyencoders performed better than the better than the biencoders at every single task, and if we actually, can you go back to the last slide? And then worse than the cross encoders at most tasks. There are some exceptions, like in these couple rows here, where this polyencoder actually did better, and up here where the polyencoder trained with more codes perform better than the cross encoder. So back to the polyencoder slide. More codes generally yielded larger improvements, which was true for most of the data sets, except for notably the Reddit data set. And interestingly, in a human evaluation study, so on Convey I2, so basically the task where they predicted like which of these sentences is most likely to have come from this conversation, the polyencoder was most like how humans responded to it, which they found interesting and we found interesting. And then more importantly, the time saved on the polyencoder is huge. So if you look at like the bi-encoder compared to the polyencoder, when you see like even on the GPU, doesn't get more than like 4 times slower than the bi-encoder, except for with, and in the CPU, it's like what, 5-6 times slower than the bi-encoder compared to the cross encoder, which is insanely slow for what, maybe a percentage point, a percentage and a half point of accuracy lost. So yeah, that's the drastic improvement of the polyencoder. And then the next thing they focused on, which was in that table earlier, is the domain-specific pre-training. So training on just the BERT pre-trained data, and then the Toronto books plus Wikipedia, and then Reddit. What they found was Reddit pre-training outperformed BERT on the downstream tasks, and on all tasks and all architectures, and the hypothesis was that because Reddit is dialogue and those downstream tasks are dialogue, that's just better suited. And also, the Reddit pre-training is the one example where the polyencoder that was fine-tuned with 360 codes actually did worse than the ones that were done with 64 codes. And they didn't really address that. I wish they had addressed that. My personal hypothesis is that if you have pre-data that's like too close to the downstream task, then overfitting is more of a risk.
Yeah, so after that section, the paper focused on their inference speed. They really want to bring home the point that polyencoders are basically the best of both worlds, more accurate than biencoders and faster than cross-encoders. So again, with the speed, polyencoders and biencoders, they have minimal difference with just like 1,000 candidates, but with scaling it to 100,000, there's 5 to 6 times slowdown, which is still much better than cross-encoder, which is more than 100 times slower than a biencoders, and 4 orders of magnitude slower, so like 10,000 times slower than a biencoders. So clearly polyencoder is much, much faster. So yeah, in conclusion, the paper introduced what polyencoders are and the methods they used on improving BERT. They discussed the different experiments carried out, including the Conv AI 2 task. Clearly, polyencoders are more accurate than biencoders and while being faster than cross-encoders. And they really talked about how pre-training from scratch on Reddit outperformed results on BERT, which is like separate from their polyencoder discussion. Yeah, that's it. Any questions?
Any questions?
So is like the candidate like a label, like the score is like the context. It's like
Looking for a label.
So one pass through the poly encoder only like classifies like one label at a time.
You repeat that?
so like
It's one of like with like multiple candidates you have to like pass through the poly encoder that many times.
Yeah, so the mechanism for the whole figure that I had up there for the polyencoder, it did show just doing it for one candidate at a time. So you'd have to repeat that process for each candidate.
does that make it like super slow if you
Let's see, it was the same structure for the biencoder as well. It also, so it's just one context at a time and one candidate at a time, which
so could you like save the output, the context encoder, so you don't have to recompute it?
yes, I believe, yeah.
Talk more about that.
Yes, you can cache both. It only matters once they're, yep. Connect with the query. Awesome.
Any other for the group? All right, let's talk about polyencoders. Yeah, I mean that was a good question. That really gets to the crux of this dynamic. So, all right, I think I'm gonna do some whiteboard stuff because yeah, and the machinery of the polyencoder is very, very dense, right? It's like this hyper-engineered thing, and the authors also do a little bit of, I mean, they kind of left some stuff to be kind of like figured out by the reader, but okay. So the polyencoders, the kind of space that this paper looks at are the space of tasks, the space of downstream tasks, problems, where you're scoring and ranking things, right? So information retrieval, QA. So when you guys use USE QA, you're using a biencoder, where it's essentially looking at your question, it's looking through a list of answers, and it's ranking which answer is the best answer for your question. Dialogue tasks, what should be the next utterance in a turn? Let's pluck out the most reasonable next response out of a set of potential responses. So it's this kind of scoring thing. Now, this paper really addresses speed and accuracy. So I'll use a whiteboard for this piece. And just look over here. Can everyone see this area? All right. So when you have a biencoder, it looks like you've got two transformers, right? They call it T1 and T2. For a cross encoder, it's one transformer. Let's just call it T. And let's look at QA, question answering, right? So there's one question. Who invented the computer? And then you may have a whole bunch of answers to many different questions. So the question comes in here. They call that the context, right? Just to generalize it. And then the answers go in, each answer goes into your T2. And then there's a score between 0 and 1 that comes out the top. And the highest scoring answer is going to be your match. Now the cool thing, and to your point, the cool thing with biencoders is if you have, say, one question and you've got 5,000 potential answers, as soon as the answer goes into the system, you can encode it once and save the vector, right? So each of your 5,000 answers can have its vector saved. Now, with a cross encoder, the question and the answer goes in at the same time, right? And then there's this little separator, let's just call it a S, which is what they call it in the paper. So it goes in the same time. So when you ask the question, you'll have to do 5,001, well, no, 5,000. You'll have to do 5,000 inferences, right? Every question. So if you see 6 questions, you're doing 5,000 inferences per question. That's a lot because of this self-attention feature, that means that the model is looking at all of the text at the same time. The model needs to see the question and the answer together to figure out its score in a cross-encoder. But here, you can cache all the vectors, right? So, you'd have a table, and then your table would have all of your answers here, and then a vector. So you only have to do one model inference for every question, and then you just look up the vector, you do a dot product or a cosine similarity. That's a very quick operation, right? It's just like a little bit of math, and you don't have to do inference on the model. So cross-encoders are slow, right, for these kinds of use cases, and in general. Now, you can use cross-encoders like this for things like sentiment analysis, where it's like positive, negative. And so your answers would just be 2. So that's just 2 inferences. So cross-encoders are interesting in that context. And it's more accurate. It's more accurate because it gets to build an internal representation with both the questions and the answers. So we like those cross-encoders. And so that's the deficiency of a bi-encoder. The bi-encoder, this model never gets to use the answer and the question together and look at it together and reason about it together. It just looks at answers, it embeds that into a space, and then it looks at the question and it puts that in a space, and then it does a cosine similarity, right? Okay, there's another topic I want to talk about, but I think I'll come to that later. And then we'll just look at it. Okay, cool. So the authors were like, well, we suffer a little bit of accuracy because this model can't see everything. So what could we do to keep the benefit of bi-encoders where I can cache my answers, right? But also let the question model get a glimpse of what's going on with the answers info. So that's actually how they frame the paper. And then, so like my critique is very subtle. My critique is there's this query code stuff. The query code stuff isn't entirely, well, we'll talk about it in a minute. So, we look at it, any questions on that? On this space of options?
So is the left one bi-encoder or is that fully encoder?
This one's bi. Bi-encoder, this one's cross. Good question. Very good question, right? Because I know, I was like, anyway, so. And feel free to ask any question under the sun, guys. Like, I had this really nice chat with a student, and he was like, yeah, people are just, these days, people are just like nervous, like they don't want people to think that, they're asking a silly question, but like, usually when someone asks a question, it just brings a sense of relief to like 70% of the other students because it's like, oh, thank God, I was thinking the same thing. Yeah, so feel free to go for it. So that's the trade-off. So this one's much faster because you'll only have to do one on a query. When a question comes in, you only have to do one inference on this guy, and then you evaluate. You do a lot of dot products to evaluate with your cached vectors, right? So that's why this is fast. However, in this case, when a question comes in, it's actually going to generate 5,000 cross encodings. And so it's slow, right? For this space of problems. And so they use some interesting data sets. Ubuntu is like forms. It's actually a very popular data set. They just downloaded the Ubuntu, like forms and turned that into a data set. There's dialogues here, wiki search, information retrieval, IR. These are all really important NLP tasks. Okay, and it's lots of data, et cetera. So this was described. Essentially, each one of these is BERT. All of this stuff is BERT, right? You got one BERT here, you got a BERT here, and a BERT there, right? So it's BERT. And then when you train it, you do a contrastive loss. Basically, let's say you're training it for sentiment analysis. So your answers are positive, negative. And then you have a whole bunch of data. And you just run the data through the pre-trained BERTs. If it gives you a 0.6, and it's supposed to be 1, you'll use that difference to train the model to bring those two spaces, those 2 points closer together, right? Cool, it's BERT. Trained in the same pre-training. They have some task-specific tuning, right? So they do some fine-tuning for each of the tasks, for the tasks just presented, but it's basic BERT, basically, MLM, next sentence, utterance. Does everybody remember what MLM is? Does somebody want to tell us? Yeah?
It means that you basically take a string of text, you hide a bunch of tokens, and have the model guess what those tokens are.
Exactly right. It's mass language modeling. Remember, it's the self-supervised training task. You're going to challenge the model to read Wikipedia or the internet or something, and then it'll look at chunks of like 10, 24 words, and it's going to randomly delete 15% of them, and then the model's going to train itself to guess those 15 correct, right? So we pre-train the model to have some knowledge about language from this generalized task, and then we fine-tune it for the specific problem as the data set like defines. Oh, answer this question or whatever. So they present the biencoder, very popular, very good architecture, you know, and it's great for similarity. I won't get into too much detail, but you basically, as was described, the group did a really, really good job at describing this. You essentially get embeddings for every word in the sequence on both left and right. And then you do a reduction. That reduction could be anything on a set of embeddings to get a single embedding. And you could just take the average. That's a very common, like the default thing that people do. If they want to get one encoding from many encodings, they'll just average them together. Very common. So you do that on the context. You do that on the candidate. This is like the terminology that these biencoders use, context and candidate. And then it gets kind of abused and redefined in later papers. But it just means the left side and the right side. In this particular task, the contexts are the questions. The candidates are the answers. In a classification task like sentiment analysis, the labels would be your candidates, and then the context would be the thing you're trying to classify. And so this really just describes the machine, your left and right, right? And you're really scoring them. OK. And then scoring is just, in this paper, a dot product. But cosine similarity is actually really popular, too. I like dot products better, because cosine similarity doesn't factor in magnitude, right? And which is a big thing, you know what I mean? So what am I talking about? If you have 2 vectors, one that's like that and the other one that overlaps it like this, cosine similarity won't differentiate between those 2, but dot product will, in a nutshell, which means it can learn more. So that's why they use dot product, but actually SBERT and so many of these will just use cosine similarity. And the nice thing about cosine similarity is it gives you a number between 0 and 1, with 1 being perfect overlap of the vectors. So it's nicer. Dot product will give you, like 0 is what means you've got a perfect match, overlap. Anyway, that's details. Anyway, so that's biencoder, right? Cool. Awesome. And the intuition of this is if you have your 2-dimensional space, just think word to vec, right? Remember word to vec? It's like you got 2 vectors, you got cat and dog over here, cat, dog, you know, shoe. You got a shoe over there. So these are closer together. And so the score you're going to get, a 1, let's say, at least in cosine similarity, or a perfect score, would be the same dot overlaps perfectly, right? So you'll get a better score for cat and dog as you score it in this space as you would cat and shoe. So that's the value, the utility of this way of training models, right? So, cool. All right, and then we talked about cross encoders, right? This is the same picture as this guy. So it's essentially, you've got your context over here, and then the candidate goes in at the same time, and the paper celebrates, and you get this self-attention across candidates and context, meaning that the model is going to have a representation that is built with all of them together, and it can learn more interrelationships, right? And so they take the first layer. Oh yeah, and then the reduction. So how do you get a score, right? Because you get an embedding out. Similarly with the other models, well, to get a score in this case, you just do a dimension reduction, right? So you get 300 elements in your vector. Use SVD or PCA to get it down to a scalar, to one number, and then use that number as a score. And you can use that to train it with the same kind of methodology. It's cross-encoder, the machine. Now, polyencoder. Polyencoder is interesting because it's, you know, the thing about the paper that's a little unsatisfying is they don't tell you why they built it like this, right? It's just, we built this thing and then we ran it and look, it works well. So they motivate it with, we don't want to cross-encode, it's too slow. We want to be able to cache our embeddings. So in this model, you can cache your embeddings. The candidate embedding there is the cacheable embedding, right, for your answers. These are the candidate embeddings, right, cached. And then you also let the inference model take a peek at that candidate embedding on its inference, right? So meaning that this model will consume both the embedding of your question. I'm just going to use question and answer because this candidate context thing is just confusing. It'll both look at your question, and it's going to peek at the answer, and so it'll get some kind of representation of the answer too when it's learning and making decisions, right, as to what the score should be. So that's great, but then they add this query code thing, right? And they don't really say why. Of course, as a researcher, I know it's like, they probably tried the easy thing and it wasn't working too good. So they just added this thing. And so in the paper, so what is this thing? So this is essentially, it's essentially a means to get something like multi-head attention. It basically lets you generate multiple embeddings. It increases the capacity for learning because you'll get multiple embeddings, not just one, right? With the polyencoder, you just get one embedding. So you can get multiple embeddings and then also learn how to decide across those embeddings. Now, describing something like this is always a little bit not so satisfying because essentially we will never know what features are being differentiated. Of course, you can postulate, well, we need multiple of these embeddings because I want an embedding that's really good at understanding the low-level features like how many syllables, and I need like another candidate that has the capacity to learn about high-level features like the emotion of the sentence, which is a little bit more high. So you're just saying I need more capacity to learn multiple perspectives on this same data, and this is a means at which they architected the model to do that. Long story short, they're giving the head of the model more weights it can use to learn, right? By giving you this parameter that effectively lets you have multiple embeddings worth of info you can have on the same context, right? And the details is you specify as a hyperparameter this m, and that m goes to exactly how many of those additional embeddings you'll generate, and then you'll actually do an aggregation of those embeddings with an attention layer to get a single embedding. Long story short, you're just letting the model learn more. Now, in an evaluation, what would you like to see? I would want to see, let's get rid of that and just let it peek the candidate embedding and train with that. Let's see how much performance you get from that. Then, let's add your additional capacity at the head of the model. Let's train it on that without letting it peak, and let's see how that performs. And then you put it all together, and let's see how that performs. So the paper didn't do that at all, and it's weird, right? Because it's okay because the paper's so good. I'm sure reviewers complained about that, but that's just a little complaint. But at least the motivation for this is essentially having a means at which at least one of your embeddings that comes out will have an opportunity to incorporate knowledge of the answer when it's deciding the question's point in a space. I'm thinking whether I should get, any questions? Go ahead.
What are these query codes? They were talking about how like they're learnable, but what exactly are they?
They're what?
They said that they were learnable like parameters.
Yeah.
But what do they like represent?
So they're vectors. They're vectors, and they amount to just weights that can learn. So the way you train these models, and this is a really interesting and important thing to reason about with a lot of these models. When you're training the models, you have this static architecture. And that static architecture is supposed to generalize to many problems, right? So when you have that static architecture, you use essentially weights configured in a certain architecture, right? So you add a vector here that functions as a key into additional embedding layers so that they're differentiated. And then you let those weights turn into whatever it needs to get the answer right, using a random process of tweaking the weights. So it's a static architecture. It essentially gives you a mechanism to allow for multiple, you can think about it as, it's like multi-head attention. You have multiple vectors to represent the one, as opposed to the one vector here. Indeed, you could apply this same infrastructure on this side too, and then let's see what those results give you. But this also lets you parameterize it. So you can actually set it to be, your M could be 1, your M could be 2, 5. It's just up to you. It's like deciding how many layers you want. And it's an empirical process to do it and see what learns best.
Yeah, so I guess, what's the difference between this and like multi-head attention? Is it just that those are like parameters that you can tune?
Yeah. So it's a parameter you can tune as to how many of those query codes you want. So it lets you have a hyperparameter, and it's architected a little different than multi-head attention, which is just a softmax. I mean, they didn't get into a lot of detail in the paper, other than just describing the architecture. Good question. So this is the poly encoder. Any other questions, curiosities?
So in this model, you said that they cached the embedding of both of the different models. And the only difference between this and a bi-encoder, that there's like one level of attention that happens between the context encoder and the candidate encoder?
Yeah. So basically, these additional attention layers, and then a final attention layer that looks at the query embeddings is the difference. And so these are the ones that are cached, right? So these would be your answers. So you'd have the green box, just the vectors cached. And these aren't cached. These are generated on the fly. Like, that's the inference task. So you'll get the question here. Your question will ultimately be encoded into a single vector. But on that inference pass, the final attention layer is going to look at, in addition to these contexts, these query codes, it'll also look at the candidate embedding alongside it, right? So all of those emb1 to emb(n) plus candidate embedding is one attention inlet to generate the embedding. And so that's the only difference. And what motivates the paper is we want to get some of the benefit of cross-encoding, and this is a way we get to peek at it. We get to peek at that answer. But it doesn't really, I don't know if their results is all, this is a bigger model, right? So of course they get better results. How much does that actually matter, right? I don't think there was an experiment that really tuned that out. And I think they were hiding something. It's all good. It's all good. Anyway, so yeah. So that's cool. Okay, so that's what this paper is about. And then the point they're trying to make is, look, we could do pretty good. We're doing better than just bi-encoder. We don't quite hit cross-encoder, right? But we have the ability to not do a billion inferences, and that's why these numbers are so radical, right? I mean, this is in milliseconds. And for the CPU and GPU, it's both crazy. But in a CPU, you can look at 100K candidates with a bi-encoder or a poly-encoder. Well, a bi-encoder in 160 milliseconds, right? That's fast. For 100,000, that's really fast. They have some very optimized code. My stuff doesn't run that fast. Anyway, even the bi-encoder stuff. And then your poly-encoder takes more time, and it's because it's a bigger model, right? They have additional stuff that it's doing. So it's like a factor of 5 in this case, maybe. But it's way better than 2.2 million milliseconds. That's a lot more than 600, right? That's like crazy. I could do one of those slides with a billion replicas just to understand that scale. But this isn't that surprising because it's kind of not fair even to put it on the same slide. Because in one case, you're running a model 100,000 times, 100,000 times, right? So, but they're just saying, look, we can do better. Yay, and so it's a nice result. But why do I seem so interested in this model? At the time this paper was written, this model was primarily huge for these kinds of tasks. And this dialogue task is a little weird because you're just picking which is the right response. So it's kind of like QA, it's kind of like ranking. That was really interesting, but then, and this goes beyond the paper, there's this paper, Flare, that their whole paper is on cross-encoders, actually. So this bi-encoder, poly-encoder, this paper didn't even look at it. It's another paper. But basically, you can take this scoring mechanism, and what this paper is trying to do is build a machine that could be an arbitrary classifier. They're actually trying to get that bi-encoder. Let's just pretend this is a bi-encoder, right? Because cross-encoder is terrible. But you can essentially get that bi-encoder to do arbitrary classification. You can build a machine that'll do arbitrary classification. And so the observation is, with a bi-encoder, 1 and 0 on the out, you can treat 0 as false, 1 as true. And you can frame an arbitrary classification task as, OK, sentiment analysis positive. Is this sentence positive? Give me a number between 0 and 1. Is this sentence negative? Give me a number between 0 and 1. And you can take a discrete number of classes and ask, is this model in the class? You can structure your bi-encoder or cross-encoder or poly-encoder in such way. So if you have p classes, you're going to do p inferences to generate an answer, true, false, true, false, true, false, and you pick the highest true. And then now we have an arbitrary classifier. And then from there, you can build an arbitrary anything model, right? And so recently, it's in the air of utilizing encoders as zero-shot models, right? And there's some out there. Flare is one, but it uses a cross-encoder, so it's slow. Like the Flare out of the box, the code for this one is out. And it's actually surprising. It actually does relatively well, right? So basically, one thing you can do with a model like this is, let's say you fine-tuned it for sentiment analysis, and it knows happy, sad, and then you're like, you want to add some more emotions, like happy, sad, angry. And then you could just not even train it and say, now you have angry, right? And angry and elated. You just add more classes, and the model doesn't even need to be retrained. And for some set of such problems, it's actually relatively effective. Indeed, so one of the special talks, so the week after you guys present final presentations, we're going to have talks. And so one of the special talk is on a researcher in my lab that's actually working in this space. Like he's actually comparing, I forget like what the final results were, but he's actually comparing the GPT style zero-shot models for text classification versus encoder style models, looking at the whole trade-off. So he'll probably talk about that too. I'll just tell him to, whatever. I don't know what he was planning. He's got a couple papers. I don't know which one he wanted to talk about, but so it's really interesting, and it's like, you know, it doesn't have to be massive, you know, like it doesn't have to be like 175 billion parameters. So there's promise in this kind of thought process for zero-shot, you know, AI. Yeah. Another really cool thing about this, this is a Facebook paper, right? Another really cool thing about this model is you can fine-tune it gradually. You know what I mean? So there's this promise. I don't see a lot of work that does this, but it's something that's really interesting. When you have a model like this, you just have to do one, you know, as you get examples and it's corrected by a user, you can let these models gradually get smarter in production. So because they're small and they're nimble. Anyway, any other questions, thoughts, comments? Cool paper. Any thoughts on the paper? What did you guys think? Did you guys enjoy reading it?
It took a good bit.
Yeah. I know. It's
Once I got past the math.
Yeah, exactly.
Encoder was the hardest part of processing it.
Yeah, which one?
What is a polyencoder was the hardest part of processing it.
Yeah. And the context of why is there a polyencoder? Yeah, that context, right? And it's weird, right? Because you could tell. I mean, how do we know bioencoders aren't good enough? This is the thing about research. It's like, first of all, I don't know. Like this is the kind of result that someone can do a debunking paper while it wasn't the intention, but they're trying to get as good. I'm sure they thought they would beat a cross-encoder. They probably started this research journey trying to beat a cross-encoder and get the benefit of the cacheability, right? Because why did they add this stuff if they're just trying to peek it? They were probably trying to destroy the cross-encoder. And they're like, oh, we can't quite beat it, but we're faster still, so let's just change the writing. You know what I mean? And so like sometimes you lose some of those tidbits in these papers that, you know, they'll just be like reports. We did this and it worked. It's like, but why? But what was the goal? Yeah.
I think we skipped that first level of attention. We would overfit.
Yeah.
Because Owen mentioned when they had, like for the one experiment, when they had the thing with 64 codes, we did worse than the one with 16.
Yeah.
So like if we had infinite codes or whatever, then that would like be excluding that, and then we'd be way overfit.
Right, and it could be, and it's two-fact. That's a great point. And this is the kind of questions that would be great to see empirically evaluated and discussed more. But the bigger the model, usually it takes longer to train, more data, more epochs for it to become generalizable. So it can kind of go, it's hard to predict whether you'll get into a situation where you're overfitting or now you got to use more data. The data needs to be tweaked and changed. That's good. Good point. Awesome. All right. Cool.
Do you think that these researchers, like if like your hypothesis of they were trying to beat a cross-encoder and failed, is there something like does it hurt them to say that in their paper? Like what would pressure them to not say we tried to beat it, we went into this project trying to beat a cross-encoder, but we came out with this other good thing? Like what is against them saying?
This is, you know, I tend to be, it's really about the taste of the reviewers. I tend to be probably like you, I would be I would love the honesty, and I understand it, and it would actually engender me more or compel me more toward the paper. But in research land, it's weird. You're always trying to minimize the attack surface for your paper. You don't want to do anything risky because in the PC review meetings, that could be used as a criticism. They could say, oh, these authors, they didn't even know what they were doing. It's really wild if you go to these PC meetings. Like papers will get rejected for the silliest reasons. And so everyone is very careful and wants to tell a perfect story all the time. And then there's an ethical boundary that one should never cross. And you have to always tell the truth, and all of your data must be real. And the ethical bar is you have to believe your own results. That one's harder people don't get into too much trouble if they're publishing things they don't believe, as long as the data is accurate and it says that. But it's crazy. I mean, in academia, papers is like a currency. It's like publish or perish, It's such a crazy, stressful thing for some people, right?
It may also be that if they're at Facebook, I know Facebook is like a very high stress environment. They might not want to say it for their supervisors to read it 5 years down the line.
Exactly. So the comment was, and it's also the culture of even the research group you're in, right? This is actually a very interesting problem. Like, I think it comes with rejection, right? You could get rejected by your boss, like, oh, you're not that good a researcher, or you get rejected from the community. It kind of creates this certain kind of not so great culture, and I think things are evolving, right? When you look at things like Archive, there's these open forum, open access review places. This is kind of helping with the culture where you could at least lock in your research as you go. But yeah, culture in the group itself is a massive, will shape the kind of research you see coming out of places. Yeah, it's a big topic. I mean, we'll have debates. Like the faculty will have debates about things are getting too competitive, and like grant writing is getting wild. Some people will do all these things to buddy up with the decision makers. It's like lobbying is starting to enter academia. What's going on? You know what I mean? Especially with DARPA grants. I probably shouldn't even say this. They might come and DARPA might show up and say, "Did you say something bad about DARPA?" No, DARPA is wonderful. Yeah. Cool. Well, you only got a couple weeks left, so use the rest of this time to connect with your group mates, create that plan. Remember, stay consistent, slow and steady wins the race, and I'll see you Wednesday. Yeah? Awesome.
Thinking about it a lot. I haven't done anything else, but the question answering thing, that like works pretty well. Like I was testing it some more, and like it's not like always accurate, but it does pretty well. Like it'll like recommend things are like treating it, but I'm into
I had a quick question. You mentioned last week, you did like a excited for some context.
Okay, does Wednesday not work?
Yeah, but I put my like lab at the time. But like I only like
No, so they have their own like interface and stuff on like a web platform.
It's too early for us.
Paper 6.
I feel like next week.
Paper 7.
We're already like Encoders has like balance, so like never after.
Same playing Benji, we both cast our click on each other.
What?
Say that I'm playing with Benji. What did I just
the question answering thing works pretty well.
API and have the same outcome every single time. You just get painter, perform this, and you can also
Yeah, no, it's like
to make it actually.
I don't know.
I know. Wait. Even these like facts, can you make like a code?
Actually, it's like that's like dependent on what like good examples. I think.
It's like earthquake, right?
We can do it. We can like we can get like with GPT-3, you can do like the few shot thing where you like give it context and then like a sample answer because it's like
And I just which is like they're so involved.
I see it coming, I use Gus to like push myself off.
Why not? How do you see yourself?
Like I was going through my Facebook projects today, and like every single like
every 4 instant bounce spell
had like some upside.
So basically the idea is like
it's like I would say
it's gonna spawn at the player speed and it's gonna like draw like they probably will. I mean especially maybe like for whole players like there will be like show on the ground. So they're gonna warn you're saying there's a warning. Okay. That's more caliber. But yeah, so there's gonna be a warning and there's gonna be like a you know what? You know Overwatch? Yeah. The new Bastion.
What turns out?
You can see how it's like the borders. Yeah, there's like a red sign. Oh yeah, you watch that basically.
I think I'm gonna go.
That's perfect.
It's the same thing as the dual fist, yeah. Somebody gets to do it 3 times. You have clearly cared since Alpha because Doom Fist has been in the game much later than that.
You're gonna say like 7 hours to find the project or something. So you're
Would that be fun when there's like the end of roles? Pick the same characters.
Diag also has a option to play over feature where you can like upload
I think there's still limits to the number of like how you do with a character. But you can have one every day.
That's not fun.
Nothing's fun. Life is suffers. Multiplayer never
It's 6 weeks.
It wasn't required, but that is
okay, so we're gonna have to like hold spells for the server to return
Absolutely, now
I just realized sitting here that there's no one there. I got a wall. Space Marines are really bad at the high frame.
Oh, how are you not wearing the scarf today? I'm freezing. I'm not looking forward to this weather. Yeah, it's like actually
Yes. We're gonna get it for what?
I need like the time completely different temperature.
It's just gonna return whatever function or intent is being
last year you don't have to hold the scarf because you had to be back on.
I do have ice skates though, so I go
Before that was best for off.
but then they're from the I've never done it before. Just sit down.
We don't care about
This could like help us like classify everything. So like we can like randomly generate spells, put them on GPT.
That's expensive. I'm not paying for it. Card's been paying for it. He gave me his API key. He's already seen it all the time.
Oh no.
Western area, I think.
Big about to run out of its free trial.
I mean, you don't have
to. So I spent $15 so far.
Exactly.
That's
why don't we
where do we
literally want to cache this spell?
We're gonna use laptop server.
Going with
No way. Can I get SJ Jackson's Raspberry Pi? I gotta get an LLC though, right?
Okay. Because what I'm thinking is like, there's something.
That's the cool thing. You get spotted by Facebook.
That's
I've yet to be there.
For example, Geeks does, right?
I'm forgetting the entire AI team. It's not free. Yeah. I should have money for voting OpenAI. Is Facebook on OpenAI? Or are they just like heavily involved in it? Not involved at all. Is Elon Musk going to share the company? These are all more responsive.
I don't like that's a little far.
Yeah, that's a little far.
I mean, then it's like, what can you do?
That's your clergy.
No, there's this when we break.
Be the majority share. Well, I'm saying we do the LLC now so we don't get Zuckerberg. Actually, that's not true because Zuckerberg is kind of giving away all his shares. Okay.
I mean, if you're willing to like copy everything.
This is like a patentable product. This is not a
Dude, I'm like making my way to the other.
product that you sell. I think.
I don't think anyone's gonna buy it.
They'll buy it as a demo. Or like a download it now.
It's not really like you have it free online.
Dude, I ran out of whipped cream in my house.
How are we gonna use a buying code when we can't make it for say? No, it's not. We're gonna come everything. I've never used Page in my life. Never used Page in my life.
You want to make it look good? Take a giant kiss and shave it over the whipped cream.
Okay, or
It doesn't like add anything at all except like a cyst.
We binge like 6 episodes.
Yeah.
Every time it makes the page. Next weekend, we pick like a day. We binge like 6 episodes.
Are there any like
No, wait.
I think we have enough types right now. Just like
you should get the ad. Language I
Whoa. I'm like 5'9" and 5'10" on a good day. 5'10" on a good day.
It's really
that's
not a good environment.
What about like
We're all
to get to 6 feet? Respectable. Hey, 5'10", that's respectable. Two is respectable.
I like Boba, but I don't remember. Oh, right.
You're not supposed to think about it. That makes it weird, okay?
I see it.
Not supposed to think about it, okay? That makes it weird. You just say something, you dap something up,
He
you're
was
done.
great. Like I didn't have him, but I watched it out of his like.
Have like a Unity like projectile, like you know, like you have Copilot or something.
You think too much, never ever gonna let anyone.
You know the
concept
concept
of
of
Unity. It's illegal.
Not gonna happen.
Depends on the
That's not gonna happen for me.
I think like
All we do is get rid of the dev text, it'll be fine.
we also need
Man,
I just want to make it even. I want to even out the playing field.
Yeah.
Hey, no matter how
I'm Timmy.
Do you think you could teach maybe like lower level stuff without this?
Hey, we're all changing.
Or like,
I'm going for like a
like when teaching something like 280 would be.
I've been on
I still have to fix my info. I still don't have my console working. Well, I haven't had a chance to work on it, so it's not today. Yeah, I'm gonna go fix it right now. Absolutely.
There's like there's an expectation of how to for like every level of education except college.
Are you religious?
Right?
Which I
Isn't that weird?
Surprises me a lot. I stand that shit.
like if you want to teach elementary,
It's just part of it. You want to teach students like parent class stuff all the way down to like.
No, but like, what do they teach?
Be able to because of the harsh band.
I don't. Okay.
But like, I still.
So you must be pretty good.
No.
Okay.
Yeah, I think that's.
I've yet to actually take music.
See, I can play music. I just don't know how to read music. I hate reading music. I hate so much music theory class. The worst part of music class is reading music.
It's taking the fun out of music.
Reading music, standard music.
I mean, my thing is that in my life,
Guitar specific.
I haven't felt that. That's sort of what happened. Like,
Yeah, this is
I mean, there. I guess like things are.
Say something on the meeting notes.
Oh yeah, I got work on the call. We are. Why are we?
We shouldn't take too long. Yeah, I mean, like we have a standing meeting. We should end the meeting. Yeah, I should actually do some work too. I don't know what's
We're good.
Are we meeting?
Would you have to play it as soon as we
Okay, I'll join remotely.
Bye guys.
Yeah, like user buying culture. The dictionary thing. The dictionary thing, yeah.
I don't think it's that. I think next week.
We'll pay for a little bit of server space. There's only a limited number of stuff people can come up with unless they just start like random words in the dictionary to screw with us. I don't know.
Yeah, let's do it.
Like they can like come up with any ridiculous spelling, which is working. That's how marketing like going.
I don't think they're gonna say like fireball.
Costing us money, we'll just make them sign up with an open AI token.
Yeah, we definitely will.
You do it very easily actually. You can just do like a OAuth to Google account. You can do an OAuth to OpenAI will give you like $10 of free credit. You do it with OpenAI now. OpenAI will give you $10 of credit or something for free for like a week. Or like 3 months. 3 months.
Yeah.
I didn't hear you and by our notification that I couldn't get those
Makes me nervous.
I'm sorry to know what Google Voice.
really bad shoes. I was like, you know, I need shoes.
Google Voice wants to regenerate
numbers pretty easily, I think. This is like fraudulent, so we should stop talking about it on the camera.
Yeah, so it's not gonna happen.
Camera right there, Tom. You're not into Tom.
I don't think it's gonna like do anything. Hi guys.
Okay, like, I don't know.
Is ripping a necklace off
Yeah,
it's
not it's just like not really in the back of my mind.
She was like, yeah.
So these decrease and I mean it's also like
these increase
twice a week, every week, and like I mean, at least for me as well,
We'll probably need to like get a
is it possible to break someone's neck?
month left.
Yeah, but I didn't want like too many classes.
I didn't read the paper. I
don't mind
filled
having
up
a
summary
class.
class just now. Yeah. Polyencoder, polytheist, polyamory, all the same thing.
The four building goes next.
Yeah.
Yeah, why not? Why are we using a SQL database for this class? Why not use a mongo?
Like Mars said something like, that's okay, in the middle of the presentation.
Yeah, but then half the FX reads like a 10-minute one.
He said something like, it's all good or something like that. Remember that? When did he say that?
No.
Did you say that because I was laughing? I started laughing in the middle of the presentation because I danced. No. He said like he made some sort of comment and he said it's all good, and started laughing. I think he went and did that because I was laughing. So my dad asked me something about Gretchen. He asked me if I voted for. He asked me if my mom voted for Gretchen. And I thought that was really funny. Gretchen. Did she vote for Gretchen? Space question mark.
Really works because we're not doing anything.
It takes 4 minutes according
But
to Google
SQL's
Maps.
fine
It
because
takes 4 minutes.
No,
That's how my database
but the
professor
issue is the
too.
computer noise is so slow that I'd rather just take mostly base and
Not because of my dad.
That's definitely.
Yeah, but the thing, the computer noise also comes to noise like 5 minutes later. And if the weather's good, that's as well. You know, bro, if there's
What happens if they don't follow the
ESG
timeline?
fix, it's that bus thing.
And
the freaking
with the computers and like she's like learning like how to implement
yeah.
They're worse than bachelor's.
Labib was asking me, giving me on Saturday or whatever.
It's hard to get like a big standard.
They were here from the beginning. They just didn't learn What code we downloaded? We all got familiar with it. All of us. Were you familiar with it? Like beforehand? She shouldn't be asking me queries after we met. She's very good at just starting the project.
Wait, who was it? Wait, you should have told me like when there.
I mean, we're gonna have to factor it into the timeline.
I want to like go.
Katie's putting more work than anybody. I mean, I'm putting more work. It's very small in comparison.
I can probably make it.
Should I like turn my face and like hide like a ostrich? Put my head in the sand. Your mouth wasn't cracked open. Benji's COVID.
I ran it through the JSON thing. And
you have COVID? No.
Yeah, I'm trying to make you.
I bet. I don't care if you have COVID. I'm immune. I just can't smell like your stuff right now.
Two, bro, I'd say one of them.
You're scared. Oh man.
Bro, you just mean there's
King.
It's still recording, bro.
Oh, wait. Yeah, Meghna Kandanaju is associated with us. I would like everyone to hear that. Yeah, it's great.
Giving away.
That's very okay, there's no way anyone's watching this after like, oh, we're doing that.
Trying to buy it.
All right.
It's been the other people if you want to try them or something. Selling it as well. No one's saying a price.
I think you said that guy, and it doesn't know where you're pointing.
This guy's selling it for $5.
Behind the camera.
Yeah, I might just do 5.
Server.
That's
funny.
Bruh.
We were talking about Elon.
You can do that, and then like what makes sense.
Yeah, I think like that could work too. We like have a single player vote. That's where like you can vet yourself, and then we go in multiplayer to like actually.
Apparently, like.
I feel like every tech company's taking that.
Yeah, I mean, they are, but like Twitter's taking the
Yeah,
biggest.
but like in general. Like,
Yeah,
I mean that's what we're doing. Like
recession.
Gonna have to send a ticket.
It's already done.
No, because I mean the point is like in COVID, it was like.
Not a real recession.
I mean, it was different circumstances because like, everyone was like at home, so like.
Carl, what other use classes do you have?
24 hours.
Like company like.
Are you on project 3 or 4?
Twitter's rehiring people because they're like.
Yeah. They realized that some of the people they fired, they shouldn't have fired, so they're trying to bring them back.
What do you guys talk about?
Like this website got hacked and they gave you like all the packet data
Yeah.
for the website and you had to kind of
That's not white chocolate macadamia. How are you?
That's why I'm only having this.
Do you think they?
Yeah, I'll take it. Is this chocolate?
This is project 2?
Can I take the one?
No, project 3 was all about like
Depending on the
I think it changed this year.
And
Dude,
and
that
now
part
and,
was
and,
nice.
and now you're working with an Elon company. So
Probably
like
like
80
more
hours.
than I think Project was like the most fun. It's
I
probably
don't know.
so
Wait, do you have to learn Ghost though?
No.
Gotta be kidding
I mean, it was a pain
I don't
in
know
the
why I
ass.
work for Danny Jeff.
Cause you had to like manage all these packets and stuff.
I normally leave Amazon
Project
for
is it still buffer overflow? That one wasn't too bad.
Bezos is
Is it still like
space
the 8 different?
I don't know, it's just 2 weeks.
Alright.
Yeah.
Okay, my only recommendation is start Project 5 as soon as possible. It is a massive scavenger hunt that will take a long time. So I started it like 5 days before, and it was a massive.
That's the worst feeling when you start a project like semi-soon. You're like, oh shit.
Well, it just so it uses everything you've learned from all the other projects. So it's just like basically all of them.
No, but this was like weird.
You guys are in
databases and
I would hope you're wrong with this.
Yeah.
See, okay, this is too much. Like most rockets aren't.
Oh wait, yeah, we gotta go lecture, we gotta go too.
Most rockets are like this. And then this works.
Maybe that was good class.
Oh, so you know how to do that?
Yeah.
Wait, what? No, I think
You don't have to give one chat.
Names,
No, if you think about
but I don't wanna like be, I don't wanna go up front and be like, it's for my friend.
is so full.
This sounds more so.
Wait, I think he meant to say dude.
Well, I'm still waiting for annexes.
My brother.
Yeah, I definitely don't
Yeah,
wanna.
I always confuse the dude and the ugly for some reason.
the Amazon
The
headquarters
ugly is
is
way
like,
better, there's more seating.
Yeah,
The dude has like no seating.
Cause like all engineering kids are like just. No, the dude's gonna fix the bathroom issue.
Yeah.
They have to like.
Wait,
am I
what's
supposed
the
to-
issue where you go?
Oh no, the fact that Ford building has like so like low accessibility.
taking shits freshman year was so much nicer. Cause like there would be no one.
What? Wait, what?
What did I just hear? Yeah, I mean.
Wait, during COVID?
Like-
Was that your freshman year?
Like fall
Yeah.
2020.
No.
That
Yeah,
was-
okay,
that
duh.
was a
Any building that would have any.
It was so nice.
We used to
Okay.
have the room.
Wait, actually,
That's your favorite part
dude,
about COVID?
I wanted to play hide and go seek at the dude, bro. Like at night, when the dude is empty.
You also want to play
So
hide and seek in
stupid.
Seattle.
Stupid?
Wait,
What do you mean it would be so fun?
downtown?
Actually, you know what this dude's idea was?
Oh, it would be like, have you
You
guys
like-
seen The Amazing Race?
Oh
Yeah,
my
so I want to
wait,
play
my
that
bro
in
Seattle.
Bro.
I know.
Bro. Nah, this dude's idea is like, he straight up just like gets somewhere in a random location without any help. Like, technology, you have to get to some other location.
God. That's not fun. That's so scary.
Yeah. No, you wouldn't get like, there'd be like.
Wait, in
it'd be-
Seattle?
Yeah, there would be teams of 3 people, right?
Wait, during the day or at night?
In day.
Wait, oh.
And like we'll all start like we'll all meet together, and then all teams will be an Uber will be booked for them, and they have to like close their eyes and they won't know where the Uber drops them off, and then they start from a location, right? But they can't consult their phones or the
Wait,
internet.
but how do you
It's
even like
pretty
prevent that?
easy though.
What do you mean?
Like, how do you prevent that?
Honor system.
Honor system?
I'll just like, yeah, it'll be. Oh no, what I was thinking was that if there are 3 teams, there'll be 3 organizers, and 1 organizer accompanies every team to make sure they don't cheat.
It's pretty easy because you can just hop on a bus and just like.
Yeah, that's the thing. You have to like figure out like which.
Hey, no
bus-
technology.
It's
no
pretty
working
easy. It's pretty easy because all the buses go to downtown and from downtown.
You know, that's the point. It's not supposed to be super difficult,
Yeah.
but like everyone like starts at a different location, right?
Yeah.
But then you have to get to like, so in the end, everyone will like end up meeting at one place.
Yeah.
But everyone has their own set of like clues which will take them to different places, and like they probably to show evidence that they've gone to that clue, they probably have to take a picture or something.
But
Right.
I don't technology.
You can get the disposable camera.
Okay, maybe.
Develop.
No, then the organizer would take a picture for, or I mean, if the organizer's there, they don't have to take a picture. But
This whole
yeah.
time to break this.
Wait, did you
the
plan
system.
this whole thing but you didn't do it?
We never did it.
No, we never did it. But I was thinking if we did it in Seattle, that would have been fun.
Do you guys
Here's the
stay
thing, half the
up?
people,
We're a pretty big group too.
Here's the thing, half the people said, yeah, that's great, and then behind your back, you're like, that's dumb as fuck.
Wait, no, everyone was like hell like vibing with the.
Yeah, and then when they went behind your back, they're like, this is dumb as
So
fuck.
that's like some off.
Do you guys sleep over at the office?
That's
Huh?
Do you guys sleep over at the office?
No.
Last
Wait, you
year.
guys could?
Last year I did that one.
Some interns like decided to just.
Actually, no, here's
Last
the thing,
year I
some
did that
people
once.
did it and posted in Slack,
Yeah.
Oh.
and then they got
You guys
kicked
have
out,
to
and then
use
they got
Slack?
kicked out.
What?
You guys have to use Slack?
Yeah.
We weren't
Oh,
allowed.
yeah, internal Slack.
It's called Workplace. It was so bad. It was literally so bad.
Sean was raving about
Sean
it.
was like, oh my god, it was so good.
Yeah.
Like,
Okay.
I mean,
Sean's
Amazon
a Facebook dick
integrates.
sucker.
Amazon
Yeah,
integrates
no,
I
Slack
miss Slack
API.
so much.
Sean is just a dick sucker for whatever company. So funny.
It was literally so bad. There was like channels and chats, but they were all in like one so it would be like channels and chats like mixed up in like your inbox. So it was just like I don't
You're
know.
telling me the company that owns WhatsApp couldn't make a better system?
Yeah, but I don't think
Yeah,
This is WhatsApp.
It was like the same it was like the same.
No, it's end-to-end encrypted,
Yeah,
so they
right.
can't spy on you. So that's why. It's,
Dude,
They
it's
would
Facebook
want-
internal.
Yeah.
They don't give a shit.
yeah, so that's why they wouldn't want people to use WhatsApp.
Just make a single encryption key that Facebook knows.
Yeah, that's why you will never be a security engineer.
I'm saying from Zuck's perspective.
That's why Zuck is taking a big L right now.
Did we lose like how much was
Yeah.
that big chunk of the
25%.
Yeah, 25%.
And now apparently
Maybe we should go to the.
they're prepping. Yeah, let's go into it. They're prepping for the biggest layoff since 2004.
Yeah. You had it before.
Since 2004. Yeah. I think it's like in terms of percentages.
Wait, did they give it up to her?
No, but like that's just what I read on the news.
Wait, so like what they like
Basically
hire like
short
new hire
Facebook.
or like whatever like
Wait, what's Facebook?
They haven't hired anyone to take.
no,
they haven't
no,
hired
like,
anyone
I'm
recently
talking
to
about like
fire.
like people
Facebook
like
ticker
interns
change
from
probably
like last year who they
I
gave
don't know.
return
It was.
offers
It's
to.
already been pretty.
How many interns did they even give return offers to?
I mean I know like 3.
Oh, I think it's a matter.
So like probably
Okay, given that you interned there and you probably met a lot
Short
of people
meta.
and you only know 3.
Yeah, it's meta.
It's probably
Big
less.
short meta.
I mean probably like
I'm only heard of one girl
Still
who
have
got
buy
it.
all. You know, still.
It's
Yeah.
so depressing. Like they were just.
I saw
finding
her.
things
She was
like-
in the.
She's in our tech ops class.
She is.
Yeah.
I think I saw her a few times. Like, her face looks familiar.
I interviewed with Meta last year. I got rejected.
That's a blessing in
I
disguise.
didn't even
Yeah.
apply to Meta because I don't want to work there.
not for big shot.
Because like they'll just steal my social security.
You have to give your SSN to whoever you work for.
I know, but like I don't. I'd rather trust Amazon than Facebook.
What?
Yeah.
There's not like a big difference.
It's also like they're not going to like spy on their own employees. They're gonna spy on other.
No, companies definitely spy on their. Like, Amazon definitely does.
Oh yeah, dude, everything.
Wait, you really
want
care?
your
I don't
laptop-
care.
But like I'd rather I'd pick the lesser evil.
Yeah, the lesser evil is not Amazon.
Yeah.
As far as employees
It-
go.
But Amazon is sure as far as
Okay.
employees.
Comparing it to Facebook.
Yeah.
Like, there's
Yeah,
not
hey,
that
bro.
much of a difference. Whether Amazon
Sorry,
has your
Meta,
data or
Meta.
Meta has
Amazon
your
is the
data.
best company in the world. It's the best company.
No, they
I
need to
think
change
it's
the
like
LP.
a
They don't even
recording.
strive anymore. They need to change the LP. It's not strive anymore.
Wait, is that like they're saying?
No, they should just be
their
am the
leaders
best.
should have been- It's so
That's
cool.
the
Strive to be the best employer.
Ours is move or not ours.
But warehousing, everyone
Move
has
fast
to
and
be
break
involved.
things.
Move fast and
They
break.
can take fast breaks.
I mean, that's customer obsession.
What's Cap one?
It's so bad. It's so bad.
Hire everyone from university.
Oh, for real? Maybe we should make them.
Wait, high key, bro. Like,
Wait, why?
I'm gonna help Olivia.
You guys should work for Capital One. That'd be so fun. Wouldn't that,
Wait,
that
where
would
you
that'd
going?
be so
Oh,
fun.
what do you
Going
think
McLean?
about Capital One? Just like make banks.
Make banks.
Make
Definitely
banking
don't
apps.
bro, all they talk about is how they're like using AWS these days.
Yeah.
That's all they talked about in the interview.
But Ming, would you want to stay
Am I-
at Cap One for like a long
Am I
time?
cap on interview
I'll
last
try
year? The dude
try
was
living
like
in DC
sucking
for like
off
a year, switch to
AWS,
New York
being
or
like,
something
yeah,
for 2 years.
you know,
and
so
Wait,
far
switch to
they could
Seattle.
only use
Seattle's
AWS,
like-
and then the next week AWS
Seattle's
went
really
down.
great.
They were out of business for like 2
Wait, what?
days.
Hair look bad.
Rain?
Yeah.
Does it get frizzy?
Yes.
Wait, then why are you going to San Francisco?
There's no rain in San Francisco.
Wait, we're just
Where is San Francisco?
No,
Not as much as
It's dry as fuck. It's California.
They don't have water.
NorCal is like hella rainy.
No.
I keep questioning.
I don't think it's heavy. Isn't even NorCal. It's like mid.
Is that like a diss?
Yeah.
I mean, it's windy though, which also fucks up my hair. So.
But it's warm.
No, it's not.
So
SF
do
is
you like it when it's
windy.
windy?
Seattle is so.
Bro, I literally wore this parka
do it,
in
do it,
SF
do it.
in
Do
July.
you like it when it's windy?
No.
I love windy sometimes.
Man, I saw this from like a mile away. I actually saw this from a mile away. Yeah, you walked just right into that.
Wait, I feel like he knew it was coming.
Yeah.
Like, he wanted it.
Hey, that's my guy.
We could have busted out half an episode by now.
Yeah. You can play here.
That would be the worst.
No,
Take the initiative, go.
He can do it on this side. On
Wait,
the left.
how much does it? I've never seen a lecture recording, so I'm
It only shows the right side.
Oh.
Actually, yeah, you can.
But the audio is still gonna be.
Yeah. It's gonna be like him confronting.
But I've lost like half of my brain cells watching those 45 minutes.
But it was so good, right?
Also, other half doing 42.
Other half doing 42, so I'm like on the last
Net
half.
zero?
I'm at a lack of, or I'm at a 0 of brain cells right now. Net 0, yeah.
Mm-hmm.
You have net 0?
Yeah.
That's sad.
You'll be there too next semester with subs.
Wait, what's that robotics class?
This semester?
Next semester? Did you say you're taking like a hard robotics
467, right?
class? Or 560?
550.
Oh yeah, that one.
Yeah.
Wait, isn't that like what? How many hours per week do you say it was? Wait, is that what 467 is too?
No, 467 is like
Oh, is that the MD?
Unreal?
undergrad. Yeah, undergrad.
That's MD? I've heard it's like pretty.
467 itself is pretty hard, but 550 is like grad.
367 is like pretty slow, right?
Yeah, 367.
Wait, are you actually taking networks then? Next semester?
I'm still thinking, like, I haven't really thought about it, honestly.
Backpacking open today.
I know, I saw that, yeah.
Fuck.
You know how influential ISA is? Wait, I don't know. Actually, I don't know if this is influential, but like, Julia Tajin or whatever,
Yeah.
literally emailed ISA and was like, "You have to advertise in backpacking."
Wait, why?
Because there's family members.
And they're against still being serious.
Yeah, she literally messaged us and was like, "Backpacking is open. Put it in your weekly newsletter."
I mean, honestly, like, what, like, I'm sure, like, at least 20% of, like, ISA members are in CS.
Probably more.
Probably, I would say it's like mostly Ross and CS,
Oh, so yeah.
What about pre-med?
And
There's
pre-med.
yeah.
and then some information kids like here and there.
Information. I barely know.
We're on board. What's the distribution board like?
Board is
Pre-med?
Wait, Brody, I need
a
some
lot of
caffeine.
Ross. I would say 50%.
Brody, I'll give you some energy.
Brody, I actually need coffee.
M36 place or whatever.
Generally, if I just get coffee, I go to Vertex, which is down
Dude,
the
I
street.
walk by
so
Vertex
good.
every day. I didn't realize
If I
it
get
was
food, I go
called
down
Vertex.
36.
Vertex
What do they
coffee
have?
for me is my favorite.
The other day, I got a dirty
I-
chai.
I'm 36 coffee worse.
I'll try with espresso. It's good.
I remember roasting company is pretty good.
I just get bagels.
I always walk by Vertex to
Should
get
ask for
to my home.
30 little
That
things
shit's still
chai.
running.
I saw a TikTok about it, like,
Dirty chais are so garbage.
Actually,
I hate them.
But wait, why is it called dirty chai?
Wait, you don't
That
like dirty
just
chai?
sounds-
Brody, whoa, didn't
They're
you?
so gross.
That's what
I
I
don't.
got.
I like it. Like I love coffee. I love the coffee taste. I love the chai taste. For some reason together. I
Yeah,
don't know.
it
I
does.
think it goes together.
Thanks for coffee. Shit's gas.
Yeah. Did you try? They have like a orange something latte.
Oh, orange caramel.
Yeah, that was good.
That's good.
And then there's like a lemon, heavy lemon something. Something like that.
I tried one, but I don't know which one it was.
The other like special one.
But yeah, cappuccinos, gas, cafe meow, gas.
Wait, is that from? That's from Ann Arbor. Oh.
I mean, cafe meow was.
Yeah. I love cafe meals.
I mean, it's just.
That's like you can make that at home so easily. It's literally
Meow. I might. Yeah, it's like French. I
honey
think
and
French.
honey and
Yeah, it's kind of.
Oh, it is Spanish.
yeah. Cafe is also French.
I mean. What? I feel like it's probably like French.
No, what do you feel? It's not a feeling, it's a fact.
I'm saying yes. They are saying
Dude.